most common form of fixed installation in the offshore oil and gas market. But their stage decommissioning will take place over several years, during which time the power to all systems will be withdrawn, including the power to aids navigation. But this is the problem that we still have to maintain the aids navigation marking scheme. So the power's been withdrawn, the top sides will be removed, and the plan is that all remaining substructures should be fully removed to the seabed, in fact, to 2 meters below the seabed. Unless that is, the substructure weighs more than 10,000 tons in air, or there have been significant structural modifications or significant damage which may make this too hazardous an operation, or for which the technology does not exist at this time. In this instance, permission to dispose in place may be sought, but will not necessarily be granted. Moving on to concrete gravity-based platforms. These were first deployed in the 1970s and right the way through to 1995, with a planned working life of 30 to 40 years. Most designs have a base storage caisson and 2 or more shafts penetrating the sea surface to support the topside structures. They go into a depth of water up to 350 meters, so quite significant structures. The picture here actually gives a comparative scale of these platforms against the Eiffel Tower in Paris, which is dwarfed by comparison. The first generation of these platforms were not designed with removal in mind. It was never a consideration. When the second generation was installed, removal was considered, but looking at it now, it might be deemed to be too difficult or unsafe because of stability issues. And so safety concerns may preclude their full removal. Now, when we're talking about these structures, the concrete gravity-based platforms, we must consider that they are extreme structures. The substructure can weigh up to 1.2 million tons in air. And the topside alone can weigh up to 52,000 tons. So we are talking seriously large and difficult structures to deal with. And this presents us, both with the steel jackets and with the concrete gravity-based platforms, with 2 primary navigational safety problems. The first is how to provide continuity of navigational marking from cessation of production through the extended removal phases of the topsides and the associated substructures to final abandonment. Bearing in mind this can take anything up to 3 to 5 years. And the second question is how to provide a long-term marking system for any remaining substructures to which there will be no access, because you won't be able to land on them. So the period of cessation of production to final decommissioning of a steel jacket may be in excess of 3 years, while a concrete gravity platform may be expected to remain standing for between 500 and 1,000 years. So they're going to be around long after any of us here are. Now, with those 2 problems, we needed to look at solutions. And given the twofold nature of the requirement to provide navigational marking in both the short and the long term, 2 possible solutions have evolved in cooperation across national boundaries between Scotland and Norway, and with support from IALA industrial members, particularly in this instance from our friends at SABIC. The solutions have to comply with IALA recommendation 0139 on the marking of man-made offshore structures, and also, given this is in UK and Norway waters, the supplementary standard marking schedule also applies. Obviously there will be regional equivalents to the standard marking schedule applicable in local waters. In developing the solution, consideration had to be given to the limitations of the currently available navigational marking equipment and the requirements laid down in and pertaining to the variances to IALA 0139 and standard marking schedule. And in this case, two systems were developed to address the need for an interim solution, which has been designated the Interim ATON Navigation, or Interim ATON, and the long-term solution, which has been designated as Rig Watcher. We thought we'd keep it simple because that's what it does. Looking first then at the Interim ATON, this addresses the need for a fully autonomous navigational aid to cover the period during which support services on the platform were withdrawn right the way through to the final removal of the topsides. And this doesn't matter whether it's a concrete gravity-based platform or a steel jacket. There's a need to mark the topsides as the stage decommissioning goes on. And what we have here is an adapted NLB CIL Type 2 buoy superstructure, which supports a 10 nautical mile light with an optional Raycon. It can remain on station for an average of 3 years, but access is required for installation and removal, and if it's staying out for longer than 3 years, for interim servicing. Importantly, as the decommissioning process progresses, the interim ATON can be moved around the remains of the platform to provide continuity of marking. The Rig Watcher, on the other hand, as an ATON navigation, is designed to provide for the long-term marking of any residual offshore structures, particularly as it is desirable to maintain the mark to IALA Category 1 standards. The design specification required that the ATON had to be a single, self-contained unit designed for replacement without anyone landing on the structure. And the Rig Watcher is therefore designed for deployment and recovery by remote helicopter lifting, and supports a 10 nautical mile light and a Raycon. It is monitored remotely via satellite and is scheduled to remain on station for a 4-year period, at which point it will be exchanged by the helicopter remote lifting. In the design specification, we had to consider the balance between ruggedness, durability, and also portability. It must be mounted securely on the structure and also self-release for swap out. To this end, the 800 kilogram unit is lowered onto a 1.6 metre docking pole, which gives the unit correct alignment and assists in a clean lift-off on removal. So how do we put this into practice? These specialised ACE navigations were developed from the need that arose from the decommissioning of the Total EMP Frigg field, which sits astride the UK-Norwegian median in the North Sea. In fact, this field provided the only bridge from the UK into Norway. The field consisted of 3 steel jackets and 3 concrete gravity-based platforms, and there was also a remote concrete platform at MCPO1, some distance away. And you can see there the layout of the field. The decommissioning plan called for the 3 steel jackets to be removed to the seabed, and the 3 concrete platforms were to have their topsides removed by heavy lift barge, and the legs were then capped, leaving the substructures in situ. And what you can see here is the 3 steel jackets would be removed, but this is what remains underneath the water. You might only see 5 small pillars and a small circle, but there's quite a significant substructure remaining under the water, and that's why it's difficult to remove them. During the removal of the topsides, all of these structures were marked with interim ATONs throughout the 3-year process. So the remaining substructures of the 3 concrete gravity-based platforms were redefined as disused structures, which permitted a variation from the standard marking schedule. Following a traffic pattern analysis A simulation study was carried out at the Ollesund University College, which assisted the development of the final marking plan.